Alright, so here we are with Unit 11, Lesson 14, and we're going to continue with organic reactions, and we should be able to finish this up in this lesson. The fourth type of organic reaction is called an esterification reaction, and an esterification reaction basically is producing an ester. And if you go back and you look at Table R, you'll remember that this is the ester, or this is what an ester looks like. And what you're looking for is this functional group. A carbon double bonded to an oxygen and then single bonded to another oxygen, but somewhere in the middle. And if you look at this, you'll notice that you can see here that that is the organic acid, that is the alcohol, that's the ester that we just showed you, and of course here is the water. So that's one way. So you have to be able to identify this as an organic acid, and the way that you would is that you look for the functional group, and that's the COOH, which is always at the end in an organic acid. And then you look for the alcohol, which has the OH, doesn't necessarily have to be at the end. And that's going to be an esterification reaction. And remember, we already named these, learned how to name these compounds here. Let me just go through. When you're naming organic acids, you're going to figure out how many carbons you have. It's 2. And you're going to put the name for the alkane with 2 carbons is ethane. Get rid of the E and then put ethanoic acid. This is an alcohol. It has 2 carbons in it. And the OH is attached to the first carbon. Either way, it's going to be attached to the first carbon. So this would just be ethanoic acid. No need to put a number. I'm sorry. This is ethanol. There's no need to put a number because since there's only 2 carbons, that OH is always going to be on the first carbon. But if you put 1 ethanol, would it be marked right? Probably. And you remember, esters are a little bit confusing. You're going to treat the oxygen that's single bonded. What's after that is going to be considered the branch. It's 2 carbons, so that would be ethyl. And then you take these 2 carbons and change the ending to OATE. So this would be ethyl, yep, ethanoate. I know, it's funky. Okay, and that's our esterification reactions. Let's look at the next one. Number 5 is basically very simple. A saponification reaction is when you make a soap. And what you basically are doing is you're taking a fatty substance, reacting it with a base, and it produces alcohol and soap. So saponification is making soap by reacting a base with a fatty substance. Don't worry about these down here. Fermentation, another relatively simple reaction. Fermentation is when you are taking a sugar and using an enzyme, and it breaks down into 2 things, alcohol and carbon dioxide. So the sugar could be glucose, fructose, sucrose, etc. That's the general format for sugars. It's a 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. You already can identify alcohols because they have an OH with carbon, and that's just simply carbon dioxide. So that is an alcohol fermentation. The last is what we call polymerization. And there's 2 kinds of polymerization. Basically, polymerization is when you take small molecules, which we will call monomers. You take small molecules and you join them together to form a larger molecule, which we call a polymer. So making a polymer is called polymerization. There's 2 ways of doing it. One way is called addition polymerization. And addition polymerization is when you take unsaturated monomers, meaning you're taking either alkenes or alkynes, small alkene or alkyne molecules, joining them together by breaking the double or the triple bond and making a long chain of carbons. Notice the single bond. So you start out with alkenes or alkynes and you end up with a compound which has only single bonds between the carbons. So you're taking small molecules, linking them together like a chain, and you're making a long chain. Now, what's the difference between that and condensation polymerization? Well, if you take a look in condensation polymerization, don't worry about these diagrams here at the bottom. What you're doing is you're taking monomers which have water in it, or H2O in it, and you're removing the water. And one of the products, of course, is going to be water. So that's condensation polymerization, is monomers joined by removing H2O. Um, is don't they do ask questions on polymerization, but the most important thing is that you know in general what is a polymerization reaction. Basically, you're taking small molecules, linking them together to form larger molecules or polymers. In one case, you're starting out with alkenes and alkynes. In the second one, you're simply doing the same basic process, taking small molecules and you are linking them together, and in the process, you're removing water from it, and that's where they get the word condensation from. And that is it for Unit